This is the completed permanent magnet statorless motor made of acrylic. It consists of magnets, an electric motor, an N20 electric motor that turns the magnets, and some electronics and a 9-volt battery to control the motor by remote. I'm using a remote controller here to control the speed of the motor. So it's got a bearing at the bottom that I got from a fidget spinner, but it doesn't fit tightly enough in the bearing to make the bearing actually turn. It's just a friction bearing. And on top, I don't think you could see in the video, but on top there's a hook hanging from fishing swivels. I think it can go a little faster. So the concept here is that the magnet stands still because it's a compass, and there's torque. There's about 2 gram force per centimeter force at the end of the magnet, and so that translates, if you take 15 centimeters from the end of the magnet to the center of the magnet, about 3 inches, that's about 8 centimeters. That's about 15 or 16 gram force centimeters of torque that this little motor is putting out and or being driven by. So that's not a lot, but you know, it adds up. So the magnets are very powerful N52 neodymium magnets, and they're 3/4 inch in diameter, and there are 16 of them there in a stack. So it was very difficult to get the axle of the motor centered, and I took great pains to make the axle straight because the axle has a big opening in the middle. It's kind of like a crank. And the top disc and the bottom disc that support the apparatus that makes it turn are connected by 3 rods. So it has 3/4 inch diameter acrylic rods connecting the top and the bottom disc together. And then the axle is in the middle of the top, and there's another axle in the middle of the bottom. And it is pretty straight. Actually, I surprised myself at how straight it came out. I just used some hand tools. I used an electric drill. I had a special drill bit for drilling acrylic that I had to order. And I did order the 7-inch discs. And it was just a matter of finding the center and drilling them. And you can see it went out of phase. And you can see what happens when it goes out of phase. The motor slows down and the magnet just spins around in a circle. So there is a little friction, and this model weighs much more than the last model. The wooden model only weighed 3 ounces without the magnets and electronics, and this model weighs about 14 ounces without the electronics and the motor and the magnets. So I'm quite pleased with how this came out. So if you like this, give me a like, subscribe. I appreciate subscribers, Rumble, and I have a link in there. I appreciate any tips. So thank you very much. Have a great day and stay tuned.